Components of a vector. In this lecture, we are going to discuss how do we find components of vector in any direction. Component of a vector along a direction is the length of the line joining the tail of the vector with the foot of the perpendicular drop from the head of the vector to that direction. That is, we drop a perpendicular from the head of the vector along the direction in which we want to find the component of the vector. The distance from the tail of the vector to the foot of the perpendicular is called as the component of the vector along that direction. Let us say there is a vector A and we want to find the component of the vector A along the x-axis. The vector makes an angle theta with the x-axis. We want to find the component of the A vector along the x-axis. We shall drop a perpendicular from the head of A to the x-axis along which we want to find the component. Now, the distance from the tail of vector A to the foot of perpendicular will be the component of vector along the x direction. Let us call it distance AX. Similarly, if we want to find the component of the vector along the y direction, we will drop a perpendicular from the head of vector A to the y-axis. The distance from the tail of A to the foot of perpendicular on y-axis will be the component of the vector along the y direction. So this is the component AY. There's one more way by which we can define component of vector along any direction, and it is the length of the shadow formed along that direction if light is falling perpendicular to that direction. So if we want to find component of any vector along any direction, we make light to fall perpendicular to that direction. The length of the shadow along that direction will be the component of the vector along that direction. So let us say if we want to find component of the vector along the x direction, we will allow light to fall perpendicular to the x-axis. So let us say these are the light rays falling perpendicular to the x-axis. We just have to find the length of the shadow formed along the x-axis. So if light is falling from upward, we can very easily visualize that the shadow will fall in this much length. Similarly, if light is falling perpendicular to the y-axis, so these are the light rays falling perpendicular to the y-axis, the shadow of the vector A will fall along this much length. So this will be the component AY. So the length of the shadow along x-axis will be the x component, and the length of the shadow along y-axis will be the y component. We can very easily say from geometry of this figure that AX will be equal to modulus of A into cos theta, where theta is the angle between A vector and x-axis. Similarly, AY, the component of the vector along y direction, will be equal to modulus of A into sine theta. Components of a vector can be found along any direction, not necessarily x and y direction only. It is not necessary that we find the component only along the x and y direction. X and y directions are arbitrary directions. The process of finding component of a vector along any direction is called as resolving the vector in that direction. That means resolving a vector along any direction is nothing but finding the component of the vector along that direction. Thus, a vector can be resolved along any direction, not necessarily the x and y directions only. So let us say this is a vector A and let us choose any direction D1. We want to find the component of the vector along this direction D1. We will drop a perpendicular from the head of A on the direction D1. The length from the tail of A to the foot of perpendicular will be the component of the vector along that direction. Let us call it A1. Similarly, let us choose any other direction D2 and we want to find the component of the vector along that direction. We will drop a perpendicular from the head of vector along D2. The length from the tail of vector to the foot of perpendicular will be defined as the component of the vector A along the direction D2. Similarly, let us take a direction D3 perpendicular to the vector. If we drop a perpendicular from the head of A to the direction D3, the foot of the perpendicular will lie on the tail of the vector A. Thus, the length of the component along the direction D3 will be equal to 0 because D3 is perpendicular to the vector A. Or we can say because the direction D3 is perpendicular to vector A, there will be no component of vector along that direction. Finally, let us choose this direction D4 which is along the direction of vector. A vector is in same direction as the direction D4. Thus, if we drop a perpendicular from the head of A on the direction D4, the foot of the perpendicular will be same as the head of the perpendicular. That is, the component of the vector along the direction D4 will be the magnitude of the whole vector. If we want to have precise mathematical expression for the components along different directions, as we have seen earlier, the component along the direction D1
is equal to A2
will be equal to A cos alpha, where alpha is the angle between the vector A and D1. Component along D2 is equal to A2, which will be equal to A cos beta, where beta is the angle between A vector and D2 direction. The component along the direction D3 will be equal to 0 because it is equal to A cos 90 and cos 90 is equal to 0, where 90 degree is the angle between A vector and D3 direction. And finally, the component along D4 will be equal to A, where A is the magnitude of the vector because it is equal to A cos 0 since the A vector and D4 direction are parallel to each other.